Hello everyone, welcome to day 2 of the notes. So during the first day we went and talked about factoring using the greatest common factor method and then just regular factoring for a trinomial. So today we're going to start by taking that the next step, and we're going to actually take what we factored and solve for x. And the way we do that is we're going to use this property called the zero product property right here. And what this is basically saying is that if you have the product of two factors and your product is 0, at least one of the factors has to be 0. So we can use that in solving for x. So in this example, we're given x minus 2 times x plus 3, and they both equal 0. Or the product equals 0. So we know that at least one of them has to equal 0. So what we can do to solve for x is to separate them. And the way I show that is I draw a T. And again, if this works for you, if you do this, that's great. If not, why don't you show me or show everyone in class on Tuesday what you do, your method, and maybe it works for someone better than this. But this I know works, so this is how I'm going to show it today. So then what we do is we write each part and make that equal to 0. So on this side we'll have x minus 2 equals 0, and on this side we're going to have x plus 3 equals 0. And then we can solve for x. So we'd add a 2 over, and that gets us x equals 2. On this side we'll subtract the 3 over, and that gets us x equals negative 3. So pretty simple. Nothing too complicated, something you all should have seen before. But most of the time you don't see it as the product of two binomials. Most of the time you see it somewhat in the form that you see down here in 1 through 6. So the first step we have to do is factor. Well, for 1 we have one extra step before, but basically we have to factor it first to get it into the product of binomials, and then we can solve for whatever the variable is. So in 1 we would solve for a. So I'll do number 1 for you, and then I'm going to have you pause the video and work on the rest of them. I am only going to show numbers 2, 3, and 4. If you had questions on 5 or 6, feel free to bring them up in class on Tuesday. But let's work through number 1. So what we have to do is we have to make sure we get 0 on one side. So the easiest way to do it is add 2 over. So that gets us a squared plus 3a plus 2 equals 0. And now we can factor. We know the factors for 2. Because it's prime, it's only 2 and 1, itself and 1. But we can add 2 and 1 together to get the 3. So that's how we can factor it out. So we're going to have, a plus 2 times a plus 1 equaling 0. And that's where we can separate it. So then we'd have a plus 2 equals 0 and a plus 1 equals 0. And then we solve for a. So we get a equals negative 2 and a equals negative 1. So those are our two answers. Because it's quadratic, we will have two answers. So yeah, go ahead and pause your video. Solve 2 through 6, and I'll come back with answers for 2, 3, and 4. Come back. So you should be getting these answers for 2, 3, and 4. If you didn't, or if you had questions again on 5 or 6, please bring up in class on Tuesday. We'll have a chance to go over any questions you guys have. But here are your answers for those. So now we're going to move on, and we're going to talk about the relationship between the square root sign, or the radical symbol, and the exponent. So we can express the square root symbol, the radical symbol, as the exponent 1/2. So for example, we have 25 to the 1/2. It's the same thing as the square root of 25, which is 5. And in general form, we have b to the 1/2 equaling the square root of b. So when we have a square root, we're only looking at the positive square roots of the number. So in this case, we have the square root of 16 equals 4. We're not looking at -4. So just the positive ones. If we needed the negative, then we'd have a negative in front of the radical symbol. So that takes us to this next question: is y equal to the square root of x a function? So take a moment to pause your video and answer A, B, and C for me, and I'll come back with some answers for you. Okay? All right, go ahead and pause. All right, so welcome back. Hopefully you did A, B, and C. So for looking at A, for the relationship y equals square root to be a function, what must be true? Pretty much the same thing for anything to be a function. Each input has to have only one output. So you can't have x be 2 and the y's be and have two different y values. That would, looking at a graph, fail the vertical line test. So just like any other function, y equals the square root of x can only have one output. So for b, then what kind of x values are we looking at to make sure this happens? We can't, if we have a negative x value, that would be the square root of a negative number. Say this having x equals, say if we did the square root of -4. If we have this, then we're looking at imaginary numbers, which aren't real square roots. So they don't really count towards being a function. So we can't have this. So what we can only have then are positive x values. So that's how the other way our x values need to be a function. So then you went ahead and sketched the shape of the graph, very basic. And as we remember from our parent functions at the beginning of the year, the square root kind of does this little tail. It starts at the origin and kind of tails off. So what that looks like in words, to answer the second part, what does the shape tell you about the rate at which the function changes as x increases? Basically what happens is as x increases, the rate at which it changes, the way at which it increases, the amount it increases actually decreases each time. So if you're looking at from 1 to 2, the square root, or from the square root of 0 to the square root of 1, you get from 0 to 1, which is 1. But if you go from the square root of 1 to the square root of 4, you're going more x values, but you're only increasing by 1, which is the same. So that's how you get that the rate actually decreases. So using what we have answer for A through C, what can we say our domain and range are? So let's start with the domain. If we're only looking at positive x values, that means that if we're going to do interval notation, our domain is from 0 to infinity, including 0. Because yes, you can take the square root of 0. Now, if we look at the range and we look at the graph, we can say that it's actually going to be the same as the domain. And we should remember that from the beginning of the year as well. So both domain and range are including 0 to infinity. Okay, so for those of us that were here on Wednesday, those of us who didn't go on the college trips, we went over this investigation at the end of class. So I'm going to fill this out. I'm going to have you pause it and try and fill it out yourselves as well. And then I'll show you the answers because most of us did it. Most of the class that was there finished this on Monday or on Wednesday, sorry. So I'm not going to go over it unless you did want to go over it again, those of you that weren't there. But I will show you the answers for them, so at least you have the correct answers, okay? So go ahead and pause your video. Okay, welcome back. So I have worked out or written down the work to show which one of A, B, C, or D is true. As we can see, C is the only one that's true. And you can go through and look for yourself why the ones that aren't true are not. But I want to move down to this next part. Basically, the property that we just proved using an example is the product property of radicals. Basically, what that's saying is you can take a radical and separate it into its factors. Why is this useful? So, for example, we have the square root of 48. We can break it down and separate it into its factors to be able to simplify it. And the factors that we're looking for are our perfect square factors. So perfect squares are anything that is something times the same thing. So if we look here, we have, I have them all listed out from 1 to 10. So 1 squared we have is 1. 2 squared is 2. 3 squared is 9. 4 squared is 16, and so on and so forth until 10 squared is being 100. So these are the most common ones we'll use. So as to use in the example, they separate it into 4, and they did that twice because 4 is a perfect square, so you can break it and simplify the square root of 48 to 4 times the square root of 3. So what you're going to do is on your own, and I'm not going to give the answers for this right now, but on your own, work out these and simplify these using the product property of radicals rule, or the product property of radicals and your perfect squares to simplify each one of these. Again, if you have any questions, I imagine C and F will give you the most trouble. So bring your questions to class on Tuesday and I'll go over them. But otherwise, we are done for today. Probably went a little bit longer, but this is still important stuff. So it's good to take the time to do it. Like I said, bring questions to class. I'm going to have a couple that I want to do together, but otherwise we're done for today. Thank you for watching, and I will see you in class on Tuesday. Have a good weekend, everyone.